Today's lecture is the last lecture of our area under curve chapter. So, till last lecture we have learned lot of concepts, we have also learned lot of problem solving skills, and in the last lecture towards the end we have learned how to find the arc length, how to find the surface area, how to find the volume of 3D diagrams using rotation. So, we could learn only the concepts, but we could not solve much problems. So, today we will take at least 3 to 4 problems in that, and also we will learn to solve some problems which are of miscellaneous kind, where 2-3 other concepts are mixed. Okay. So, before that I will just take you through quick recap of what we have done in the last lecture. So, here if we want to find the arc length, so our curve is not strictly parallel to x axis, it could be anyhow. So, we are taking help of the derivative to find the arc length. So, basically if we take this root of dx square plus dy square and integrate this, we are going to get the arc length. Now, depending on with respect to what variable you want to integrate, you can take the terms which are common. So, if I take dx common, I will get f dash inside the derivative, but integral will be with respect to x. If we take dy common, I will be getting dx by dy inside the integral, and the integral will be with respect to y, then you may have to change the limits. Okay. And for curved surface area, what we have learned was, we have taken a strip here and we just rotated it to get a disk. Now, the perimeter or circumference of that disk will be 2 pi into y. So, 2 pi y into arc length, if we integrate this part, it is going to give us the curved surface area. So, again if you want to integrate with respect to x, you take the dx common. Okay. Next, to get the volume, again we take one small strip here, the height of this strip will be y. Now, if we rotate this, the area of this disk will be pi y square. If we multiply pi y square with dx, it will give us the volume. So, that way we can get pi y square dx as the volume of the strip, and integrating it will give you the volume of the entire surface. Now, here our rotation is always happening with respect to x. X is our axis of rotation. If you want to use axis of rotation as y axis, you may have to derive formulae on your own. Okay. But the ideas are same, so you can also explore it if you want, but we have already actually crossed the borderline of the syllabus. These ideas are not part of the syllabus, but these ideas will definitely help you in physics. Okay. So, can we solve some problems on these? So, this is our first problem, where we have to prove that circumference of a circle is 2 pi r. So, to get the circumference of the curve, we have to first define the curve. So, here if we take any circle, let us say the center of the circle is origin, that means this is my x axis, this is my y axis. So, equation of curve will become x square plus y square equal to r square. Okay. So, here only statement is from the pure geometry, but when we are approaching this, we have to define coordinates, we have to define curve. You should not do any mistake in that. Now, we want to find the overall circumference, but we know that it is a symmetric diagram. So, what we will try to do is, we take the curve only in the first quadrant. So, if I take the curve only in the first quadrant, I can write the curve as y equal to root of r square minus x square. I can write it like this. Okay. Now, if I find this arc length only from here to here, and if I multiply that with 4, I will get the overall circumference. So, I can say that this circumference is equal to 4 into integral of, again root of 1 plus y dash whole square into dx. We know this formula, but for that we need to differentiate this once. So, if I differentiate it, I get 2x plus 2y y dash equal to 0. This will give us y dash equal to minus x by y. So, I just have to put it here. root of 1 plus it becomes x square by y square into dx. Now what about the limits? X is basically varying from this 0 till r. So that means limits have to vary from 0 to r. Now here if we simplify this a bit, we get 4 into 0 to r root of x square plus y square divided by, we will get y here. Y is nothing but root of r square minus x square dx. Now root of x square plus y square is basically r, that is the radius, and we can take this r also common. So we will get 4r into 0 to r dx by root of r square minus x square. So we know this standard integral, this is sin inverse of x by r. So we can write this as 4r into sin inverse of x by r going from 0 to r. Now if I put r here, I will get pi by 2. If I put 0, I will get 0. So overall I am getting 2 pi r. Okay. So this way we can find the arc length. So using this idea, you can also find the arc length of parabola, arc length of ellipse and so on. But when it comes to ellipse, the integral will be little bit tricky. So you can explore it or you can leave it. But this is the idea of finding the arc length. Okay. Come on, make a note of this. Okay. Can we move on to the next question? So prove that the curved surface area of cone is pi rl. So when we talk about cone here, this cone has to be right circular cone. So what is the meaning of right circular cone? It means the axis of the cone must be perpendicular to the base. So here right means axis of the cone must be perpendicular to the base, and circular means the base should be circle. So it is a cone. Now we want to find the curved surface area of this. We know that this curved surface length is basically L and the radius is small r. Okay. So these are the given parameters, given values. Now how do we approach this problem? To approach this problem, again we have to design a curve and we have to rotate it. So suppose let us say I have taken a function here which is a straight line function, and if I rotate this straight line about this x axis, it is going to give us one cone. Okay. So if I rotate this about x axis by 360 degrees, that is complete rotation, it will give us a cone here. Now the radius of that cone will be basically this height, which is r. Okay, because when we rotate this, we are going to get a cone like this. So this radius is going to be r, and from this origin to here, this length is going to be h units. So I can take this as, let us say, small h here. Okay, so that means this entire length is h. Now we want to apply the concept of rotation here. So what we do is we take a small strip. Let us say I have taken one small strip here, and let me take this distance as x and the thickness of this strip as dx, and this height is going to be y. Now using similarity, we can directly get relation between x, y, r and h. For example, here we can say that y by x is going to be r by h. So y equal to x into r by h. We can take this as the y in terms of x as the f of x function. And now we will apply the idea to get the surface area. What is the idea? When we rotate this line, this strip is also going to rotate. So it will be a disk. What is the perimeter of that disk? It will be 2 pi y. When we multiply the perimeter with the arc length, arc length is basically root of 1 plus y dash whole square into dx, and when we integrate this, we are going to get the surface area, which is the curved surface area. Okay. So now how do we proceed? We have to design the limits, we have to get the derivative and put it there. We have to write y in terms of x. We already have written y in terms of x here. Now we just have to get the derivative and get the limits. Now when I differentiate it here, I will get y dash equal to r by h. So that means in place of this, I can straight away put that value. So what are we going to get? 2 pi into, in place of y, I can put x into r by h. In place of y dash, I am going to put r by h dx, and x is varying from 0 to small h. Okay. And we know that this slant length is L, slant height is L. So L can be written as root of r square plus h square. We can use that to simplify this term. And we keep only variables inside the integral and take all constants outside. So what do we get here? 2 pi into r by h, and this term will give us L by h into integral 0 to h x dx. Now when we simplify this, what do we get? We get 2 pi r L by h square into x square by 2, limits going from 0 to h. So when we put h, we will get 2 pi r L by h square into h square by 2. So this 2 got cancelled, h square also got cancelled, and we just got pi r L. Okay. So this way we can find the curved surface area. Okay. Come on, make a note of this. Okay. Can we move on to the next question now? So next question is about the volume of the cone. So for this question also, we will use the same idea and same setup. So let's say, and here also we have to take a right circular cone. Okay. So let's say our curve is a straight line like this, and we have taken, when we rotate this, we will get this as the radius. So this is, height is r, and from this point to this point the distance is h, and basically we are taking one small strip here. This distance is x, thickness of the strip is dx, height is y. Now when we rotate this, we are going to have one disc here. Now the volume of that disc, we will start with that volume and then we will proceed. Okay. So the area of that disc is going to be pi y square, and when I multiply this area with the dx, I am going to get the volume of that disc, and now I have to integrate. So when I integrate this, I am going to get the volume. But what about the limits here? Limits are going from 0 to h. Okay. So limits must be taken going from 0 to h. And here if we observe the function, we have already written the function here, which was x into r by h. Okay. So that means in place of y, we will substitute x into r by h. So what do we get here? Integral 0 to h pi into x square into r square by h square dx. Take all constant outside. So pi r square by h square, these are all constants, we have taken them outside. So what is left here? 0 to h x square dx. Now when we perform the integration, what do we get? Pi r square by h square into h cube by 3. So now when we cancel out h square, we will get pi r square h divided by 3, which is basically the volume of the cone. Okay. So here if you observe, these ideas are actually very simple ideas, yet very beautiful ideas. Okay. Come on, make a note of this also. Okay. Can we proceed now to the next problem? So here the question is about finding the volume of the sphere. Now to find the volume of sphere, again we have to design a curve and we have to rotate the curve. When we rotate the curve, we should be getting the sphere. So if you take, let's say, complete circle and rotate it about a axis, which is the diameter of the circle. If we rotate this by 360 degrees, we will get double sphere. Basically, it's a sphere which will come 2 times. So the rotation must happen only for 180 degrees. So instead of this, if we take only one semicircle, rotate that by 360 degrees, we will get the complete sphere. So basically, I am going to take only one semicircle, okay, and I am going to rotate this to get the complete sphere. This is the idea. So again, if I just take only this part which is in the first quadrant and rotate this completely, I will get semisphere which is half of the sphere. So if I take only this part and perform the integration and double this up, I will get the total volume. So volume should be equal to 2 into integral of only for this part. Okay. So again, what is the idea? We take a small strip here. That means basically I have taken a point here which is x comma y, which means this distance is x, thickness is dx, height is y. So by taking pi y square, I am going to get the area of the disk. So this pi y square, this will give us the area of the disk. Now into dx, if I integrate this starting from 0 to r, I am going to get the volume of the sphere. So here we have taken the simple idea, we have formulated everything, we have constructed everything. Now job is to integrate and find the final answer. Okay. So how do we proceed? 2 pi, it's constant, we can take it as common, 0 to r. For y square we have to write in terms of x. So what is the function here? We know that this is a semicircle which is going to satisfy this equation, x square plus y square equal to r square. So in place of y square, I can write r square minus x square into dx. Now further we can split the integral and perform the integration. So what do we get? 2 pi into r square into integral dx 0 to r minus 0 to r x square dx. So what will be the integration here? 2 pi into r square into, here integral is x 0 to r limits, and here x cube by 3 0 to r limits. Now further when we simplify this, we are going to get 2 pi into r cube minus r cube by 3. So if I take r cube common, I will be getting 1 minus 1 by 3. 1 minus 1 by 3 is basically 2 by 3. So this will come out to be 2 pi into r cube into 2 by 3, which is same as 4 by 3 pi r cube. So this way we can find the volume of the sphere. Now similarly you can also find the surface area of the sphere, curved surface area. Also you can find the volume of paraboloid. If you rotate parabola, then what happens? If you rotate ellipse, then what happens? So these things you can also explore on your own. Okay. Come on, make a note of this. Okay. Now let us solve some miscellaneous questions. So till now, these ideas of rotation and finding curved surface area, these are all for your general knowledge and for your interest in the subject. Also these may help you in physics or chemistry also up to some extent. Now we will solve some questions which are of miscellaneous type in this chapter, which may cover all topics that we have studied till now. Okay. So let us look at some questions. So one question is, find the area bounded by the curve f of x equal to x plus sin x and its inverse function between the ordinates x equal to 0 and x equal to 2 pi. So to find this area, we have to first understand the original function and its inverse function. So area is bounded, it is already given. So that means these f of x and f inverse of x, these two functions must be intersecting at some points and they must be forming some closed loops. So how do we find those values? Here this function cannot be inverted. Algebraically finding the inverse function of this function is going to be tough. So we will not go for the algebra of the inverse functions, we will directly go for the graphical way of doing it. Now to find the graphical way, to find an approach in graphical way, again there should be some basic idea of the points of intersections. So when we talk about the solutions of f of x and f inverse of x, basically solutions on geometry becomes the point of intersections. We know that f of x and f inverse of x are basically reflections about y equal to x line. So that means if f of x and f inverse of x are intersecting, they must be intersecting on the line y equal to x only. So that means here we can say that if we solve f of x equal to f inverse of x, whatever are the solutions, this solving process is equivalent to solving f of x equal to x. So solving f of x equal to f inverse of x is equivalent to solving f of x equal to x here. So that means if I solve x plus sin x with x, what do I get? I get sin x equal to 0. So wherever sin x is equal to 0, the original function and its inverse are going to intersect. So basically what are the functions that we get here? What are the values? X equal to 0, pi, 2 pi, 3 pi and so on, n pi, we will get all these values. But our interval is between only 0 and 2 pi, so we will take only these 3 points of intersections. Okay. So with this we got an idea of the points of intersections. Now how do we proceed with the graph? There are two ideas here. One idea is to use the addition of graphs. So how do we understand this addition of graphs? There are two functions here, y equal to x is one function, y equal to sin x is another function. So let us say we draw the graphs of these two functions. So this is going to be y equal to x function and this is going to be y equal to sin x function. Now when we add these two functions, what happens? Basically heights get added. So that means at 0 both curves have 0 height, so point is at 0 only. Now at pi by 2, one value is at 1, the other is at pi by 2, so net result will be this much height will be incremented here, so resulting point will come here. Basically I am taking some checkpoints. So 0, pi by 2, pi, 3 pi by 2, 2 pi, like this I will take some checkpoints and then I will use common sense and draw them. Okay. So at pi, height of one function is 0, height of one function is pi, so the point will come here. Now similarly at 3 pi by 2, one value is minus 1 and the other value is here, so it has to go 1 unit down, so point should come here. And at 2 pi, one value is at 0, other value is at 2 pi, so the point should come there. So if I join all those points using common sense, we are going to get a smooth curve like this. Okay. So how did I draw this graph? Just by adding two graphs. So you can learn this technique of adding graphs. This will simplify your process of drawing graph. Now this is our f of x graph. If this is our f of x, what about f inverse of x? F inverse will be complete reflection of the same graph about y equal to x line, right? So this way we can draw the graphs. Now what is the bounded area? Bounded area is this complete area of these two loops. So if I just find this area and multiply that with 4, I will get the required area, okay. So this is basically the idea of the problem, to identify what is the area and how to integrate it. That we will do little later. So here if you observe, we have basically understood the function, understood the problem algebraically, then we went for the geometry. Now when we go for the geometry, there are two ways. One is to go for the addition of graphs. The other idea is to go for the calculus, taking help of calculus to draw the graph. Suppose let us say you do not get this idea and you want to take help of the calculus. So how do we do it? We have already developed an algorithm. You can just follow that algorithm. So here there is no symmetry, there is nothing. So you can just go for the simple study of the derivative. So if I take the function y equal to x plus sin x, and if I differentiate this, I am going to get 1 plus cos x, and we know that this is always a non-negative number because range of cos x is from -1 to 1. So when we add 1 to it, it becomes 0 to 2. So this is always a non-negative number. So function will never decrease. It is either strictly increasing or it is constant for a while. Now if we check the points where derivative is 0, we will get this point as x equal to, which point it is? Cos x must be -1. Cos x is -1 at pi. So in the interval 0 to 2 pi, there is only one value at which derivative is 0. So ideally speaking, this is the point where derivative must be 0. So here this point must be point of inflection. So using this also we can draw the graph. So at 0 the value must be 0, at pi value must be pi, at 2 pi value must be 2 pi, and function is strictly increasing initially. And also you can check the double derivative and see if it is convex or concave. Suppose if I go for y double dash, I will be getting minus sin x, and from 0 to 2 pi, 0 to pi, this is going to be negative. So it is convex up. So the graph must be somewhat like this, and at pi derivative must be 0. So it is constant for a while, and then again it has to increase, and it will increase with concave up style, okay. So this way also we can draw the graph by taking help of the calculus. But this is one idea which you can always explore. So in today's lecture I have given you another idea of adding graphs. You can always use this idea. You can also explore adding 2-3 graphs later on, okay. So now how to get the area? Now we are going to the area part. So we have observed that the area is symmetric about y equal to x line, and these two loops will be having the same area. So if I find this part and if I multiply that with 4, I will get the total area. So the area will be equal to 4 into integral of, what is the function which is above? See, if we take the y equal to x line here, so the above function is the x plus sin x function, and the below function is the x function. So we have to subtract x from x plus sin x function, okay, and integral is from 0 to pi here, okay. So now it is a very silly integral, you know how to do this. So 4 into 0 to pi sin x dx. So you know how to perform this integral. It is going to be minus into cos x going from 0 to pi. So that is minus 1 minus 1. So it becomes 8 units. So 8 is the area of this closed loop, okay. So this way we can solve the question. But in this question there are actually 3 segments that you have to understand. First segment is the algebraic deduction. This is the algebraic deduction. Second is how to proceed with the graph. In graph there are 2 techniques. One is the addition of graphs, other is the calculus help. Now third is the integration, okay. So now when it comes to the graphical analysis, till now if you kept on watching my lectures, throughout these lectures in different chapters of course, especially from the calculus point of view, I have explored lot of ideas. There is symmetry of graphs, there is shifting of graphs, there is compression expansion, there is addition of graphs, what happens when modulus comes, and what happens when there are rational functions, ratio of polynomials, what happens when we have to multiply graphs. I have explained all these ideas. You need to make a notes on these techniques on your own by heading graphical transformations and keep those techniques with you. They will help you a lot, especially in the chapters of calculus. Okay. Come on, make a note of this question. This page also. Also this page. Now let us solve another problem. Here a n be the area bounded by the function y equal to tan raised to nx and with x axis between these two ordinates. We have to show that this relation is valid. So here question is not about finding the exact integral. Question is about sandwiching the integral between two other integrals which may have a proper integral. So here a n may not be a proper integral, because if you check a n is going to be tan raised to n x integral. Okay, so a n is basically going to be integral 0 to pi by 4 tan raised to nx dx, and this cannot be directly integrated without help of reduction forms or something. So this is not exactly a proper one. Okay, but we have to generate an inequality here. So what we will do is we will try to sandwich the integral between two functions. Okay, so this idea of sandwiching a function or sandwiching an integral, I have discussed in definite integration, where I discussed this idea of limit of a sum or using integration to find the limits, and similar idea I will use here. So we will start with, let us say, tan x function. If I draw the graph of tan x between 0 and pi by 4, then what will be the graph? Let us take this as x axis, this as y axis. Let us say this is 0, this is pi by 4, and at pi by 4 the value is going to be 1. Now graph of tan x will be somewhat like this. We can take this as, let us say, graph of tan x. Okay. What about tan square of x? Because value of tan x is between 0 and 1, when we square it the value is going to reduce. So the graph of tan square will be further down. What about tan cube? It will be even further down. What about tan power 4? It will be even further down. So tan raised to nx, if we take n to be a natural number, tan raised to nx, the graph of that will keep on going towards x axis as we increase n. So here we can just say that in this direction if we proceed, n basically increases. So if I am taking a higher degree of n, higher value of n, the area is going to be reduced. So if n tends to infinity, of course the area will tend to 0 here. Okay. So this is one idea that we have observed. So using this idea, we can say that an and an minus 2, if I let's say compare these, an plus 2, out of these, which one will be the highest one? Whatever is the least out of these two, n minus 2, n plus 2, out of these three, whatever is the number which is least will be the highest area. So, an is definitely less than an minus 2 and an is definitely greater than an plus 2. So, basically I have sandwiched an between these two. Now, if I add an all three sides, so I will get 2an less than an plus an minus 2 and 2an must be greater than an plus 2. Okay. Now, finding the sum of these two integrals is going to be easy. How do we say that? Let us take any integral of this form, ak plus 2. So, what happens to this? So, ak is basically going to be 0 to pi by 4 tan raised to k x dx plus ak plus 2 is going to be 0 to pi by 4 tan raised to k plus 2 x dx. Now, if I take tan raised to k x common, so what do we get here? Inside I will get 1 plus tan square x dx, and we know that 1 plus tan square is basically sec square x. So, it is going to be integral 0 to pi by 4 tan raised to kx into sec square x dx. Now, derivative of tan x is basically sec square. So, this comes in our standard form, which is f of x whole raised to k into f dash x dx. So, what is the integral of this? It is going to be tan raised to k plus 1 x divided by k plus 1, limits going from 0 to pi by 4. So, the value will be 1 by k plus 1. So, when I take k and k plus 2 here, the value is basically k plus 1, which can be taken as the average of these two values. Okay. K and k plus 2, the middle term is k plus 1. So, it is the arithmetic mean of these two numbers. So, for this summation we can use something like this, for this summation also we can use something like that. So, what is the relation that we got? 2an is between an plus an minus 2 and an plus 2. Now, for this, what is the average of these two numbers? It is n minus 1. So, we can write 1 by n minus 1 here. So, 2an is definitely less than 1 by n minus 1. Similarly, here also this 2an is definitely greater than 1 by n plus 1. Now, further if I divide with 2, I get an less than 1 by 2 into n minus 1 and an is definitely greater than 2 into n plus 1. So, this way we can prove the required inequality. So, here if you observe, basically we have used the sandwiching of the graph between two functions to solve the question. Okay. Come on, make a note of this also. This page also. Okay. Now, I will move on to the next question. So, here question is find the area bounded by this curve. So, only one single curve is given and it is said that find the area bounded by the curve. That means it must be a closed loop somewhere. So, whenever we proceed with any question, we also have to check the mathematical validity of that statement. For example, here LHS is a perfect square. So, LHS is non-negative. RHS is not a perfect square, but for equation to be valid, the RHS must be non-negative, which will give us a condition that x minus x square must be greater than equal to 0. So, now if we simplify this, we will get x is belonging to 0 to 1. Thus, that becomes our domain. No, not so fast. There is also one more troublesome function, which is the sine inverse x. We also need to check the rules of sine inverse x. What are the rules? X must be belonging to minus 1 to 1. Now here if we observe, luckily that part becomes the common intersection part of both domains. So hence it becomes our final domain. Okay, it becomes our final domain because that is the intersection of both parts. Okay. So our domain is going to be 0 to 1. In this domain, whatever is the integral, whatever is the situation, we have to handle that. Okay. So now, if I let us say solve for y here, what do I get? Y equal to sine inverse x plus root of x minus x square. This is one function. We can take it as f1 function, and y equal to sine inverse x minus root of x minus x square as the other function, f2 function. Now some students or some teachers directly do it like this, because when we take the difference of these two functions, we will be left with only this square root part. So some students directly say that area is equal to integral of 2 into root of x minus x square dx, and they directly use the integration like this by solving these two and getting the limits. Because we already got the domain as 0 to 1, students generally put 0 and 1 here as the limits and try to solve this. But solving this way is wrong. We need to get the confirmation from the geometry. So we have to hit the graph to before we go for the integral. Let us hit the graph. Now again, to draw the graph, there are two ideas. One idea is you can go for the calculus part, or you can take help from the ideas of the calculus, or the other idea is you can go for the addition and subtraction of graphs. So here I am going to use the second idea, which is the addition subtraction, which is going to be comparably faster than the calculus part. So here what I will do is I will draw the graphs of both functions, I will add them and subtract them. For example, between 0 and 1. Okay. If I draw the graph of the root of x minus x square, basically here there are two parts. One part is this, one part is sine inverse. We know the sine inverse function, which is very standard function. So at 1 the value is going to be pi by 2. So the graph is going to be somewhat like this. And here also at negative side it will be somewhat like this. Okay, so we know this graph. And root of x minus x square, it will be 0 at 0, 0 at 1, and at 1 by 2 the value is going to be 1 by 2. So it is going to be somewhere here like this. Okay, this is our second graph, this is our first graph. Okay. So we do not need the negative part here because our domain is only between 0 to 1. Now let us look at these two graphs, let us add them and also subtract them. So when we add them, what happens? I am adding the graph in red and subtracting in green. Okay. So let us take some checkpoints. 0 is one checkpoint, both heights are 0, so point is at 0. 1 is one checkpoint. At 1, one height is 0, other height is pi by 2. So the value is at pi by 2. And one more checkpoint I will take, 1 by 2 if I put. So one value is going to be 1 by 2, the other value is going to be pi by 6. So I have to add this height here. So the point will be somewhere here. Okay. And here also you can take some more values, but not required. You can also use simple common sense analysis and draw the graph. See here, if you notice, both are basically increasing at same pace at 0. So sine inverse x has generally slope 1 or something, but you do not need derivatives here. Because both are increasing, the net result is also increasing. So the value must increase here at a faster rate, and one is increasing, the other is also increasing, but it is slowly bending. That means its increment rate is slowly decreasing. So after reaching this point, okay, so I'll just draw the graph. So after reaching this point, the graph has to further increase, but it has to slowly increase, because this value is reducing, it is one value is increasing, but the other value is decreasing. So it has to slowly increase, somewhat like this, okay. Or the graph could be like this also. We don't know the exact graph, but we can roughly draw the graph, okay. So this is our rough graph. Now let's look at the other case, that is in the green. Initially, if we observe, both are almost equal, so the difference is positive. So the value will be somewhere positive here, okay. Now we have not yet declared the exact value of the derivative here. So we don't know which graph is above and which graph is below. One graph could be above also. So the value could be negative also, we don't know. It could be negative side or it could be positive side, but we are only qualitatively analyzing the graph. And here if I subtract this much, the point must be somewhere here, and if I subtract 0, point must be here only. So the graph must be either of this shape or of this shape, but either way the green graph is going to be lying below the red graph. So here we can observe that these two graphs, green and red, do not have any intersection between 0 to 1 except at the extremes of the intervals. So this is our graphical confirmation. That is why you need not go for the derivative, and this does not take much time. We just have to qualitatively analyze points and hit it, okay. So now that we got the confirmation, the area required will be the area between these two. So that means between 0 and 1 we can directly integrate. So what we have written has become accidentally right, but we should not be writing this directly, okay. Now how to proceed? Just go for the integral. So here I can take 2 common and write this as 0 to 1 root of x minus 0 into 1 minus x dx. We know this type of function, it is a very standard function. Whenever we have this type of function under root, what is our substitution? X equal to alpha cos square theta plus beta sin square theta. This way we can find. So here in our particular case, we can take x as 0 into cos square theta plus 1 into sin square theta, which becomes basically sin square theta. So I am basically taking x equal to sin square theta. That will give me dx equal to 2 sin theta cos theta d theta. This is clear. And 1 minus x becomes 1 minus sin square theta, which is basically cos square theta. So now when I simplify, what do I get? 2 into integral of root of x, that will give me sin theta, and 1 minus x under root will give me cos theta. Dx will be 2 sin theta cos theta d theta. And what about the limits? When x is 0, sin theta will be 0. When x is 1, sin theta would be pi by 2. So limits should be 0 to pi by 2. So this integral got converted into a standard form like this: 4 into 0 to pi by 2 sin square theta into cos square theta d theta. So you can either convert this into multiple angles of trigonometry or go for the reduction forms. So now you know the standard reduction forms. So I m comma n can be written as n minus 1 by m plus n into I m comma n minus 2. So here reduction happened on n. So you can choose any one n here and reduce it, okay. So we can write this as 4 into I 2 comma 2, which is same as 4 into 2 minus 1 by 2 plus 2 into I 2 comma 0. What exactly is the I 2 comma 0? I 2 comma 0 is integral of sin square theta d theta going from 0 to pi by 2. And you know how to handle these integrals. Again we can use the reduction forms. So it becomes 4 into 1 by 4 into 1 by 2 into I naught, which is same as pi by 2. So 4 by 8 into pi by 2, which will give me pi by 4 as the required value. Okay. So this way we can perform the integration. So here if you observe, the curve is basically looped around itself. Okay. In that given domain, curve is looped with itself only. For that, without going for blind integration, before going for blind integration, we should get the confirmation from the graph. Now when it comes to graph, we can directly use addition of graphs or subtraction of graphs instead of going for the calculus. Okay. Come on, make a note of this also. Okay, this page also. Also this page. So here basically we have taken this as the function 1, this as the function 2, and when we subtracted f1 minus f2, we got this function, because see here if you subtract f1 and f2 from f1, you will get 2 into root of x minus x square. Okay. So accidentally whatever the blind algebra that we applied, it came out to be right, but do not go for blind algebra. Okay. Next, let us say there is another question. If the area bounded by y equal to f of x, x axis, and the ordinates x equal to 1 and x equal to b is something, find f of x. So basically what is given here in the question is this: 1 to b f of x dx is basically given as b minus 1 into sine of 3b plus 4. Okay. Now here instead of b, if constant was given, then getting the function would be a very big headache. But because b is a parameter here, we can differentiate this with respect to parameter both sides and get function in terms of b. Okay. So that means let us say if I differentiate this both sides, in LHS we have to apply Newton-Leibniz theorem. So put the upper limit and derivative of upper limit with respect to b, minus put the lower limit into derivative of lower limit equal to derivative of the RHS. So it becomes b minus 1 into 3 into cos 3b plus 4 plus, basically I am applying product rule, sine of 3b plus 4. Now further if I simplify this, what do I get? F of b is equal to something. So in place of b if I put x, so I will get f of x equal to 3 into x minus 1 into cos of 3x plus 4 plus sine of 3x plus 4. So this becomes our function. So this is actually very silly question, but when you see this question, you may not be getting the idea directly. So I have discussed once. Okay. So we will move on to the next question directly. Okay, next question. 0, 0, 2, 0, 1, 1 by 3 and S be the set of points P satisfying this. Then find the area of S. So P 0, A, it means distance of P from OA. This means distance of P from OB, this means distance of P from AB. So let us take a triangle here. This is O, this is A, this is B. So if there is any point P here and we want distance of P from OA to be less than the distance of P from OB. So to understand this inequality, let us look at the equality first. Where would the point P lie if both distances are equal? It will lie on the angle bisector. So there is one angle bisector here. So on this if P is there, then distance will be equal, but we want the distance of P from OA to be lesser than the distance of the OB. So that means our point should be lying below this line. Similarly, when we compare for the other side, so there will be another angular bisector here and our area should be below this. So that means basically we are talking about this area. Okay. Now how do we find the area? So let us not take these coordinates, let's take these distances as, let's say ABC. These are the side lengths. And this is the point where angle bisectors are intersecting, which means that point is the incenter. Now from this incenter, the distance of any side is basically going to be in radius. So what is the area of this? Suppose let's say if I take this point as I, what is the area of this triangle OAI? It is going to be half into base into the height, which is the in radius. Okay. So this way we can get the area. Now let's look at the length here. A point is given as 2, 0. So this distance is 2 units and B point is given as 1, 1 by root 3. See, these 3 points happen to be the vertices of equilateral triangle. So this will be 1/4 of it. But otherwise you can get the in radius directly and get the solution. Okay. So this way you can solve the problem. On this question I also used to give one probability question. I used to say a question like this. See, I have directly fast forwarded because we don't have much time. So my question is like this. If triangle has sides ABC, let's say there is a point P inside the triangle. My question is, what is the probability that if we select any point randomly inside the triangle, what is the probability that the point P is closer to the side A than the other sides? Question becomes same, and again we have to go for the same area here. Okay. So this way we can calculate the probability to be A by A plus B plus C. This also you can verify using the same idea as the earlier question. Okay. So here, because we have seen that the triangle is going to be equilateral, so we just need one side which is 2 to get the in radius, and we know that in radius is going to be, this is 1 by 2 into 2, it is going to be side by root 3, it is going to be side A. If we take the side as A, it will be A by root 3. So if we just simplify it, we will get 2 by root 3 as the required area. Okay. So you can get the numbers later. Okay. Okay. So I think we have closed.